Can India claim its place among the electronic giants? China, Taiwan, South Korea, Japan? China controls scale. Taiwan dominates semiconductor manufacturing through TSMC. South Korea integrates chips to devices through giants like Samsung Electronics. Vietnam undercuts on cost and speed. And then there is India. Not dominant, not leading, but moving. This is not a hype story, this is a structural climb. Because the real question is not whether your phone is assembled in India, the real question is how much of it is deeply manufactured in India. Is there a consumption production imbalance? India today produces only about 3 to 4% of global electronics. Yes, it consumes nearly 15%. In 2025, India's electronics market is estimated at roughly $160 billion. By 2030, that number could rise to $300 to 500 billion. The global electronics device market is about $1 trillion, which means India is a massive buyer but still a relatively small producer. That imbalance matters because when consumption rises faster than domestic production, dependency rises, trade deficits widen, strategic vulnerability increases, supply chain exposure deepens. The real story here is not manufacturing, it's dependency. The conversation is not about pride, it's about leverage. If India continues consuming at scale without building component depth, it risks becoming permanently dependent in a sector that underpins AI, telecom, defense, EVs, and digital infrastructure. This is not this is not optional industrial policy, it's strategic positioning. There are also the four stages of electronics power. No country woke up one morning with advanced chip fabs. Electronics capability evolves in layers. Stage 1. This is the assembly. This is where India began. Smartphones assembled, consumer electronics put together, imported components integrated domestically. China started here in the 1990s. Vietnam followed similar sequencing. South Korea's early industrial journey also passed through assembly. Assembly builds workforce discipline, export logistics, quality systems, industrial familiarity. India is firmly here, but assembly alone keeps value addition limited. So this is where the stage 2, that is the modules, comes in. This is where real depth begins. Modules include camera modules, printed circuit boards, battery packs, displays. India is gradually moving into these areas. Battery manufacturing expanding, partly driven by EV demand, PCB ecosystems are strengthening, camera module manufacturing is feasible with capital and tech partnerships. Camera and batteries are not science fiction problems, they are scale, funding, and ecosystem problems. So, depth is built layer by layer. Countries don't leap to semiconductor dominance, they stack capability. Assembly trains the workforce, modules build supplier ecosystem. Ecosystems enable packaging. Packaging precedes advanced fabrication. Sequencing is a strategy. So, what about semiconductors? What is the myth and the reality behind it? India has put its foot in the semiconductor space, but let's separate design from fabrication. Indian engineers have contributed to advanced chip designs, including work related to 2 nanometer architecture within global firms. India is firmly part of the Global Design Club. Countries active in advanced chip design include the United States, United Kingdom, Israel, India, China, Japan. Design capability is distributed. Manufacturing capability is concentrated. Advanced fabrication today is dominated by players like TSMC and Samsung Electronics. Building an advanced fab requires tens of billions in capital, decades of process optimization, materials science mastery, yield engineering precision. Designing 2 nanometer chip is not the same as manufacturing it at commercial scale. Now there is a stage 3, mature node packaging and outsource assembly and testing. This is where India can realistically scale next. Semiconductor packaging and testing, OSAT, integrates chip into usable systems. It builds semiconductor handling expertise without immediately competing at bleeding edge nodes. This stage is strategically smart. Then comes the stage 4, advanced semiconductor fabs. This is the summit, and this is where realism is necessary. India cannot skip stages, it must build capability before scaling here. You don't win by jumping, you win by climbing. India's semiconductor ambition must be layered. Packaging first, selective fabrication later, design Depth before dominance. So looking at all the information above, is it possible for India to achieve 25% production of global electronics device market? The global electronics market is around $1 trillion. Some suggest India could capture 25% by 2030. Let's put guardrails on that. For India to hit 25%, it would need over 250 billion in production with strong component depth and export strength. Possible only if multiple structural forces align. Large-scale supply chain shifts from China, stable decade-long policy consistency, rapid infrastructure upgrades, ecosystem density across suppliers, global geopolitical alignment. That's a high bar. A more realistic trajectory, if India transitions from assembly to component depth, starts with camera and battery, which are technically easier to achieve as compared to fabs, which require billions of dollars, India could aim for double-digit global share over the next decade. Higher upside exists under favorable global realignment, but not automatically. Double digit is strategy, 25% is scenario. The discipline target is depth, not headline share. If depth increases, share follows. If depth doesn't increase, share stagnates. So, how is India placed competing against structural giants? Let's acknowledge the antagonist clearly. China's scale dominance is unmatched. Taiwan's semiconductor precision is decades ahead. South Korea's vertical integration compresses cost and time. Vietnam's cost competitiveness remains powerful. These are optimized ecosystems. India is not competing against beginners, but India has strengths. Massive domestic demand projected at $300 to 500 billion by 2030. Deep semiconductor design talent, policy momentum behind manufacturing, geopolitical positioning as a diversification alternative. Japan offers an interesting case study. Japan is not leading advanced node fabrication like Taiwan, yet it remains a powerhouse in materials, components, and electronics technology. Electronics leadership is layered, not binary. So, in the case of India, indispensability beats visibility. Assembly makes you useful, component depth makes you indispensable. That's the difference between being replaceable and being strategic. So, how is India placed against the global structure of electronics industry? China's scale, TSMC manufacturing leadership, South Korea's vertical giants, Vietnam's cost edge, and India climbing from assembly to modules to packaging towards selective advanced fabrication. The ambition is real, the constraints are real, the opportunity window is open, but not permanently. If India remains at assembly, it will stay replaceable. If it deepens into component semiconductor capability, it earns leverage in a 1 trillion global market. This is not a sprint to 2 nanometer fabs. It is a disciplined industrial climb. And the real question for the next decade is simple. Will India stop at assembly or will it move deep enough into the value chain to matter? That's India's journey. And this time the outcome depends not on rhetoric but on execution.